So happy to be back here and see everybody showing up for some new fun Elixir. I'm here to talk about some of the fun things like tiny computers and making lights blink. Nothing more satisfying than making lights blink on a tiny computer. So I'm here to talk about Nerves project and the state of things, where we're at with Nerves and some of the updates that we've been able to put in over the last couple months, years. But first, I'm sure that there's some people who are new to seeing devices like these and hardware and the Nerves portion of what you can do with hardware in Elixir. So just a little overview of what it is. Nerves is essentially kind of like you take Erlang and you put it together with Linux kernel and some Linux utilities, and you can ship it off as a product that you can then run on a standalone device. It can target a lot of different kinds of embedded hardware or even desktop machines. Yeah, essentially you just take your application that you get to write in the happy path where we all like to be in Elixir and Erlang. In the end, you put it together with the OS, and you have your full runtime. So here's a nice little overview picture of what that kind of looks like, the paths that we go down, right? Because we want to do all of our work on our computer and not on a Raspberry Pi or like a little device, because that's slow. This is fast. These are really beefy machines that we can compile on. And so that's sort of the top path we're all used to. Build an Elixir application, write all your logic in there, bring in some dependencies for your project. And then out of the other end of that, we build an OTP release using Distillery to be able to then you have your OTP release. And on the bottom there, we see Nerves also has these things that are tool chains. And a tool chain is essentially a cross compiler and utilities to be able to compile code like C code and stuff into, to compile it on your machine, but for this embedded target. And we also have these Nerves systems that we supply as well. And you can kind of think of that as the underlying OS components. And then in the end, we marry those two pieces together to make a firmware bundle. And this may look overly complex in a way, but the simplistic view is to say, like, we're all used to this pattern. Elixir app, OTP release, drop it on a web server. We're familiar with producing web applications. But in our case, it's just, instead of putting it on a web server, you take your Elixir app, you make an OTP release, and you drop it onto an embedded device. From there, when it starts to blur together a little bit more, you can kind of consider this like it would be a container or a virtual machine that would be living in your cloud service provider. But it just so happens to be able to do some more fun, interesting things, one of which is blink lights. But there's more that it can do, and we'll talk about that. So it's nice to then understand, like, okay, well, what can we do with this on this device? Why is it a good way to lay this out? Like what's happening on this little Raspberry Pi on the SD cards that we have. These are typically used like tiny little hard drives you can think of. And here's a general perspective of what our deployment looks like. From the web world of things, you'd know this as a sort of built-in blue-green deploy strategy. This perspective right here is that of like a Raspberry Pi. That's because Raspberry Pi requires to have this boot partition, as you notice. But we split the partition tables up to where we have an A and a B slot for the boot and the root file systems. And that allows us to be able to have a fallback utility. So with Nerves and embedded hardware, it's pretty important that you don't brick that device in the field. That's a pretty bad thing. And so to prevent that from happening, we put a lot of work into countermeasures and strategies like this. Where let's say you're booted off of partition A and new firmware comes in. Well, we stream that new firmware into slot B, and then what you can do is you can boot into slot B and see if everything's good and validate it and say that you're going to continue to stay booted off of slot B. And then when the next firmware update would come in, well, you'd stream that over slot A and you can just ping-pong back and forth between the two. That way you always have a known good working copy that you can revert to in the case of something goes wrong, or the user updates and they didn't want to, you can revert that back. And the nice thing about Nerves is that the tealish, bluish color ones up on the top, not the yellow one, that's all that stuff that's mounted as read-only. And so, we all are familiar with, well, maybe the concepts of immutability in Elixir, and the kind of guarantees and safety that provides us. And this is just a way to be able to extend that feeling of immutability and safety to the runtime. This is important for situations like tiny machines where the user, you never know, they're just going to expect that you can just pull the power out at any moment. And then it's just going to power down, not gracefully all the time. So having that mounted as a read-only is going to prevent corruption cases. But we do understand that you're going to have some sort of state that you need to persist. And that's why at the bottom there we offer the application data partition. That's a place where you can actually, it's mounted read-write. You can write your files there. You can write stuff like state, and that stays persistent between the two if you boot back and forth. So it's kind of like you think of that as like, your migrations. Like if you, like a database, or you want to put data there, you'd have to make sure that you migrate that forward with your versions if you want. But that's basic perspective. And the nice thing is that these systems, when they come packaged, when you put them together at a minimum, you can get firmware down to like 30 megabytes. And that's your application, Erlang, the runtime, Linux, like everything you need to be able to boot that board. And it kind of lends a little bit of absurdity when you start buying SD cards that only come in like 8 gig like sizes. You should use like 30 megs. So yeah, that's fun side effect. You get a lot of wear leveling, I guess. All right, so what does Nerves run on? It's really funny. Prior to this, I was showing some of these slides to Frank. Frank's like looking at the top line, and the top line used to say like Raspberry Pi A and B and like 2 and 3 and 3A and 3B plus and like 0 and 0W, and it's like every Raspberry Pi made ever. Just say that. All right. So yeah, every Raspberry Pi made ever. Compute module, it's going to be supported in there. So, in addition, the BeagleBone series, they probably make more than these. So maybe most BeagleBone, well, no, the BeagleBoard, I guess you could say. But BeagleBone Black, Green, Blue, Pocket Beagle. These are different boards that are a little less common of names, but they're really great for industrial usage. There's actually a wonderful company that makes the Octavo, right? Octavo? Yeah, the Octavo chip. It's basically all of the components and packaged all together into a system on a chip that you can just plop down onto a board, and it does a lot of the heavy lifting for you. And they're reasonable, and so this, because of its open hardware designs, lends itself a little bit better for manufacturing your own custom boards. And it might be a good solution and choice for if you're trying to be able to spin something custom that you need to put in the field. Also supports x86 machines. Speaking of 16 gig SD cards, it's so fun to be able to buy like a machine that's got like a terabyte hard drive and then use like 100 megs. Yeah, but this list isn't just it. I mean, Nerves uses Buildroot under the hood, which is, this package that allows us to be able to cross-compile a lot of the things out of the box. But it's got a lot of great support for additional embedded Linux hardware. So just because it's not on this short slide doesn't mean that it can't run Nerves on it. So if you have questions, you can definitely reach out to us, and we can help you figure that out. And so that's what Nerves is. Well, let's take a look at what's new in Nerves. And from the top, the massive thing that got the least amount of mention in the release notes for Elixir 1.8 is quiet. Like mixed target, which was a Nerves thing, is now officially supported up in Elixir. Just like you would set mixenv to be like your environment. Mixed target is now a top-level item, and so it's the idea of multi-target is definitely getting pushed forward and embraced in the language as a whole, which is great. This actually afforded us a lot of wonderful changes. One of which, as I'll show you, is we have unified dependency lock files now. Prior to Elixir 1.8 and mixed target coming up, we had the lock files, you'd have one lock file for every target. So like if you're on your host, you'd have a lock file that would be like mix lock host. And if you're on like a Raspberry Pi, it would be like mix lock rpi. And the problem that this had was, well, if you update dependencies, depending on what target you had set, the dependencies would only get updated for the lock file for that target. And then you'd switch targets and you'd just compile and deploy and you'd be like, why is this code breaking? I updated this dependency, but it's a different lock file. Now all that goes away and makes it so that it's all one lock file. That means that projects are going to come up a lot cleaner as well. You'll be able to switch targets a lot faster because all the dependencies are fetched at the beginning instead of trying to be able to fetch them each time you would switch targets. And one of the other big things that we're going to show you here is that the new project generator, we've done a lot of work in there to be able to help get projects up and running quickly. And so we added a lot more helper functionality to that to make it even easier to get started. So what do those changes look like in our mix files? Well, instead of having like 3 or 4 different dependency sections that all get convolutedly compiled together, in the end, depending on what target you're on, it's all in one depth section. So it's a lot more unified and concise. And in this example here, this is showing also a situation where we have multi-targets. Our choices are Raspberry Pi 0 or a Raspberry Pi 3A. You can see there's a new keyword option that was added to support this feature, which is the targets key. And in that targets key, it's similar to for only, where you say like you want only dev and test. Targets in this case can take a list or a single atom. So in the case of the all targets there, that's something that gets expanded by default with the new project generator to just be a list at the top of all the different targets that your project might support. And then at the bottom, we can see our specificity goes down. Without declaring targets, that's going to be something, a dependency for all of them, including host. If we specify targets list of all targets, that's where we sort of saying like, okay, this is for all of the other targets except for host. At the bottom there, we can say we're specifying single ones, and those are just specific targets, like when you're set for Raspberry Pi 0 or 3A. That's to swap that nerve system out underneath. So what does this do? Well, as I was saying, we not only unified the dependency lock files, but now the dependency structures are unified. So in pre-Elixir 1.8, we can see that this is the deps directory. Under the deps directory, we'd split by targets. So you'd say like deps for host and deps for rpi 0 and deps for rpi 3. And it just had a lot of duplication in that case. And now Elixir 1.8 and on is going to have them all just in the same deps folder. Doing a lot of cleanup on redundancy. Now this benefit didn't come without some pain uncovered. For that, it really started to manifest itself when it came time to do C compilation. So if anybody's familiar with like projects that have some C code that needs to get compiled in them, usually you can use like Elixir make, which is great. But somewhere along the lines, I think that our practices, we kept them out of convenience. The practice usually is that you compile it in the source directory and toss the files into the privdir. And then whether or not you have build embedded turned on, it would like symlink it or like copy them. But the issue being still that the build products were being placed in the privdir. And the issue with this when it comes to unifying the dependencies is now that if you were to switch targets, you would, and Elixir make gets executed again, it would see that it already has built files in the privdir, even though they're for the wrong target, and it wouldn't build them again. And so the problem that you encounter in this case manifests itself as an error that fortunately gets caught by our scrub scripts that we have, which when you produce firmware in the end, that firmware bundle, We validate all of the binaries to make sure that they're going to be compiled for the right executable format. And so in this case, we can see here, this is an error that you'd see come out where it's trying to be able to verify that it's getting what it expects. And so in this example, this is, I was switching back and forth between Raspberry Pi 0 and Raspberry Pi 3, and it never recompiled this dependencies C code. If you encounter this, you can clean all your dependencies and fetch them again. It flushes out the source directories, right? That's like not the answer I want to give you, but it's but the reality is that the real answer is that this practice needs to sort of change. And so we've had a lot of discussions that we opened up on Elixir Make when it came to talking about this. And the product that came out of it was essentially from the start as a test. We took all of the places in the C code that Nerves compiles for, and Frank went through meticulously and took every one of those projects and moved it to be able to refactor the make files that Elixir Make takes with some additional, to accept some additional environment variables so that it can be told where the build directory is, so that instead of building stuff in the source packages in the privdir, it would get built in the under build directory so that those things would get recompiled when you'd switch targets. It works really well, and I think that it's beneficial for us as a community to be able to try to move forward in this direction because it seems a little irresponsible to compile output files in your source directory. And especially in this case, it'll make everybody's lives easier. So right now, we don't have anything written up yet, but our plan is to be able to try to put some information together that's a little bit more of a guide-based or an overview of why things do what in regards to how you can, if you have a project that has make files in it and uses Elixir Make, how you can contribute to structuring your project to not only make it a little bit more friendly so it can be cross-compiled, but also that it builds under the build directory as well. So right here is just a screenshot of a package, Nerves WPA Supplicant, which is a place if you want to check out this pull request that was closed for now. Like I said, we're going to be working on something to be able to write up for that. All right, and so how do you upgrade your projects is another thing. I'm sure a lot of people have some projects out there that need to be able to move forward to be able to support this. Well, all of this feature is available on Nerves 1.4 with the official support for 1.8, Elixir 1.8. And we have a guide that's up on our docs, on Hex docs. If you look for the updating projects section, you can see on what's required to be able to migrate your project from a pre-1.4 to a 1.4 project. There's not a lot there. It's actually, you're going to be deleting more code than you're really changing, which is great. So we all like those kinds of PRs. And the other thing too is that when you're getting updated, there's sort of two components to Nerves on your machine that you interact with. One is the Nerves dependency that's going to be in your mix file for your projects that are Nerves based. But the other is going to be an archive that's installed called Nerves Bootstrap. And that archive sort of serves two functions, one of which is that it's responsible for setting up the environment during compilation time. So it points to the right cross compilers and things like that. And the other portion of it is to generate new projects. And so in this case, if you already have Nerves Bootstrap installed, you can update just by calling mix local.nerves. That'll just go through the process and make sure that you have the latest version of the Nerves Bootstrap utility installed. If you don't have it installed yet, there's other dependencies. Make sure you go check out the Getting Started guides, but you can install it directly through Mix by calling mix archive.install hex Nerves Bootstrap, and that'll bring it down on your machine as well. So all of this is great, and talking about it is fun, but hardware is so, I mean, it's a physical thing, right, in front of us here. So it's fun, even more fun to be able to play with. So one of my favorite slides, demo. All right. So here we go. I've got an SD card here. I've got a Raspberry Pi 3A board. It's really cool, new boards. It's basically a Raspberry Pi 3 power, but on a smaller footprint with what's known as gadget mode. Even in the back? Maybe bump it a little, yeah? Yeah? All right. So just got a new project here. So we're just going to do mix nerves.new, and we're going to call it my app. And right out of the box, we can see fetch and install dependencies. Sure. We're going to really test that conference Wi-Fi out today, aren't we? Right? All right. Look at that. Generated project. Yeah, woo! All right, so that's the new project generator. There's some additional options you can get into if you want to, but out of the start, we can just do this one, cd into my app. And here we go. We got our project structure, and we can see here our new mix lock file format, or our new mix format. Got all our dependencies in here, and here up at the top we see we got all targets. It's just basically a list of all the different targets this supports. And so the first thing I'm going to do is I'm going to say export my mix target, because I want to compile for RPI 3A. And let's right away mix firmware. So like I said, I was saying, if you're new to Nerves, mix firmware is a Nerves command that performs the work to first compile your app, and then it builds an OTP release. And then when it's done building the OTP release, it takes the pre-compiled Nerves system, in our case, Nerves system RPI 3A, and it will put it together with your application, and out comes an FW file in the end. So I already inserted my SD card, so now I can say mix burn. It'll recognize I've got well, roughly 16 gig SD card in there. Say yep. Type in my super secret password, 1, 2, 3, 4, 5. And all right, done. Pop it out, put it in the back here, and plug her in. The other great thing about this new Pi here is that you need a special cable, an A to A cable, but it supports what's known as gadget mode. So over this USB, it gets power. It's also opening its own virtual Ethernet and serial port. And so from here, we should be able to SSH to nerves.local. And if everything worked out according to plan, voila. Here we are in an IEX session that's running on that device. So that's how quick and easy it is to actually use the new project generator and get up and running. One of the main changes that was made recently was, if you're familiar with Nerves, using this kind of setup, we used to have a flag that you'd pass. It would be a -- init - gadget. And it eventually came down to the point where we were just like, I'm always generating projects with this flag. Let's just make it the default. So the latest version of Nerves Bootstrap does that. It makes it the default. And if you didn't want those helper utilities, you can turn that off with similar to how you would with like Phoenix, where you say like no ecto, you go like no init gadget as the flag there. All right. First successful demo down. Thank you, thank you. I like that you clapped that the demo was a success, and not that he booted on a Pi. Wow. It's all right. We'll work on that. We'll work on the amaze clap, right? Okay. We'll get there. We got more to go. Okay, so now we can boot onto these devices. It's really cool. Tiny computers. IEX session on a tiny computer. What can we do? Some math calculations, I guess. You can do 1 + 1, right? Hope that equals 2. But you're going to find yourself quickly getting into situations where you need to be able to do some debugging. And debugging is a little different on, well, not different, but there's a couple quirks that you fall into. One of which is that there's an issue with the regular logger. And the issue is, well, I should probably switch these slides. I'm going to jump around here. I'm going to go to this one first. There's an issue with the regular logger. And the regular logger's issue is that it's called the console logger, but the default one. Right? And if you think about virtual computers, right? You think about that. You think about like how you have a machine that can have like virtual machines on top of it, and then you're like, oh, I want a remote desktop to these, but I want the console session, right? That's like you're like that's the one that's actual like the actual terminal session, or the actual like one that's on the machine, you know, not like a virtual session. That's a similar situation in this case. And that logger will send log messages to the console. And the console on these tiny standalone computers is essentially just like wired to the display. I mean, there's an HDMI port on this. And so if you were to plug the monitor in, you would see log messages coming out there. That's how we would expect the console to be. It's like as if you would plug a display in and a keyboard. The problem, though, is that as you've noticed when I SSH to Nerves local, most of the time that we're interacting with these devices, we're interacting with them through some remote connection means. And because of that, those log messages don't get delivered to remote connections. So to solve the problem, we ended up bringing this package in called RingLogger. We built this package called RingLogger. And RingLogger has a couple features. First off, one of the main features is that you can use the ones attach and detach. And what that allows you to do is it allows you to log into using a remote session. You can call attach, and it will tell the RingLogger instance that's running on the target that you're like attaching this process ID to it, and that all log messages that come through will actually show up on your remote console. Then you can detach if you don't want. You can even grep the logs. And because the reason it's called RingLogger is because it's actually an in-memory circular buffer of log messages. And the reason that that's important is because let's say when your tiny computer boots, you encounter an error following like just when it starts up. When your SSH connection joins, it's too late for you to attach and catch the error because it already happened. So you're going to want to know like what happened before you arrived. And if we look here, that's this next message. And we'll see that in a bit. I'll do a little play around with that. And then we also have this, this other one called Toolshed. Toolshed is a helpful package that contains a lot of different helper functions as well. I'm just realizing that I needed this one yet. Toolshed's nice. It's like, you know, your fingers when you type at the prompt, sometimes if you're used to like Linux, you're like, oh, let me see what the IP address of this node might be, like ifconfig, and you're like, oh, right, you know, I'm in IEX. And your feeling might be able to like drop out and go to some like bash shell or something. But in this case, we want people to be more comfortable in using, being at the IEX shell and being able to ask for that kind of information. So Toolshed contains a lot of helper functions to be able to look at some of that common stuff, like network configurations, IP addresses. You can even TCP ping some stuff to be able to make sure your connections are up. As well as TOP's a really fun one, yeah, seeing like process outputs and stuff, that's cool. And we'll look at a couple of those too when I see this one. All right, so that's nice. Well, and we just burned using an SD card. How do we update firmware? Well, let's say you're going along and you're programming and you encounter this error and you fix it and you're like good to go and you got it. Now you're like, okay, I want to push this to my device. Well, over using SSH, just like we do connecting to Nerves the local, we can push over SSH the firmware. So let's take a look at doing that. So we'll go back to our same session here that we have. And let's say we have this problem that we fix in this app. Let's make a more meaningful change. So we'll go into my app here, and instead of saying hello world, we're going to say hello Lonestar Elixir 2019. Hey. Really important change. Anytime you make a change like this, you're going to have to package it together. You mix firmware, and that'll compile and build a new firmware release for you right away. And takes a tad, especially when you're screen sharing. It's fun. So next thing I need to do here is as a little bit of ceremony, I need to, we have an easier way to be able to write firmware. I mean, pushing firmware over SSH is pretty, the command that you need to do it it's not that big, but we generate this helper script for it to be able to alleviate some of the quirks on doing it on certain host machines. Like Mac OS has some problems sometimes resolving multicast DNS names, and it's a little helper function. So at this point, I use mixedfirmware.gen.script, and I can just call upload, and it'll just stream that over the connection to the device. And you can see it upgrading partition B. It's because we started on partition A. And then it'll shut it down, reboot it, and it'll boot into the new firmware. And the interesting part here is that since we're streaming new firmware, we're not just updating the application. Like if we had a system level update, like we wanted to bump the version of Linux or something like that, that's part of the underlying system. That all comes with it too. So they're married together, they're locked together, and that makes it a lot more approachable to understand like what's happening when it comes to trying to be able to figure out when problems occur. Like you can know that it's all locked as a dependency together. So we should be able to do nerves.local SSH back in here. And once we're in, we can say my app.hello, Lonestar Elixir. Yeah. Thank you. All right. That's cool. All right, now pushing firmware over SSH gets old after some time, and sometimes it's not actually the most ideal deployment strategy. When you start to move your devices past like 1 or 2, it becomes a little tedious. And so we've sort of I've encountered this myself. There's a lot of other companies that encountered it as well. And so over the last year or more, we've been working on building a service called NervesHub. And NervesHub is a means to be able to try to go to the next level past firmware pushing over SSH. And the idea is that we have this central server, and your devices, it's a Phoenix-based app, your devices connect to it using Phoenix channels. And your devices can be managed so that it's, as they grow, not just 1, not just 2, not just 3, but your whole fleet can get sort of like packaged up into like different deployment groups. And then NervesHub, you can, similar to pushing a package to Hex, you push your firmware to NervesHub, and you can just deploy it out to individual devices or groups of devices at once. So in a nutshell, you take your firmware, you upload it to NervesHub, and it gets downloaded to your devices. And it's, I can't stress this enough how much we've invested in making this as secure as possible. We use client-side SSL to be able to validate both ends of the spectrum, to make sure that the computer that's pushing firmware is who they say they are, as well as the server, and to make sure that the device connecting to the server is who they say they are, as well as the server. But more importantly, too, we also give the ability to the developer to sign the firmware file itself with a key, so that way you have the confidence to know that when the firmware goes through NervesHub and comes out the other end, that it's the exact same firmware and that hasn't been modified. And so built into this mechanism are that it will only trust certain keys that you have control over, and that's built into the firmware as well. And then to go one step further, we also started a project called Nerveskey, which is a tiny little crypto chip board. It's based off the AT-ECC 508A, 608A series chips from Microchip. And it's this tiny little I2C device that costs less than $1, like 60, 70 cents or so, to be able to add. But in our case, we're trying to be able to manufacture add-on boards that are very easy to be able to put onto like a Raspberry Pi. It'll just solder onto the back, or you can just hook it up with some wires if you want. And the idea here is if anybody's familiar with what an HSM is, it's a very similar concept. It's a hardware security module. And so, you hear a lot in the news about like IoT security problems, like people just having like public key or private, or I should say private key information just sitting like on like an SD card, like that's just then nobody's going to be able to get it. Yeah, and then the news breaks out and it's a nightmare. This is a case that tries to get, like, it secures that. Like, the private key information is generated on this chip. It doesn't leave this chip. And using some plugins like the SSL engines for Erlang, it connects in line so that all of the delegation for computation against private keys is handled by the chip itself without, like, in the background, like, so that you don't have to worry about that. None of the information is outside of it. So this is like full end-to-end security that we're trying to be able to really drive and promote people towards. Frank's been doing a ton of work on this, and here's a picture of the board itself and how teeny tiny it is. That's either a really big quarter or that's a small board. Here it is on the back of a Pi Zero. So you can actually solder them right to the back, which is a great layout for it. And yeah, so these are not available yet, but they're just about to go into manufacturing on them, and we're going to try to be able to put a storefront up, and you'll be able to buy them pretty inexpensive cost. And it really does, when working with NervesHub especially, let your life easier. Oh, I should also mention, this isn't just going to be like a NervesHub thing. Like, the certificates that you store on this device are going to be totally compatible to work with Amazon IoT as well, Azure IoT systems, so that you can use the same certs that you use to authenticate your device with NervesHub with all of those other services as well. So there's about NervesHub, there's 2 different ways to use it. We have hosted NervesHub, which we host at nerves-hub.org. And on that system, there's trial accounts available. The idea is that we're going to build that up to where it's a very reasonable priced system that people from anywhere from enterprise to makers can get onto and use to be able to not have to worry about the hosting. It's completely scalable and secure. We've invested a lot of time and energy into making sure that the system itself is always up and scalable. But I want to stress that there's NervesHub, all the code for NervesHub is open source and available on our GitHub repositories. And so if you wanted to be able to run your own instance of it because you want to have control over your firmware update delivery mechanisms, you can definitely just take that and launch it on your own. At that point, then it's you can have unlimited accounts and it's all managed by you. So the scalability, that's up to you then. And with NervesHub, we've also done some work recently to split out the portion of it that communicates with our API. And back when this launched, it used to be called NervesHub Core. We've migrated this to a new namespace that made more sense called the NervesHubUser API. And the reason I'm showing this slide is because this is a common piece that we've started to find with some people that where you already have like a backend server that your devices were connecting to and just talking with. And you want to be able to add some code to that backend server that helps you transition to moving your devices to be managed by NervesHub. And so you can use the API, and if it's Elixir, you can just drop this NervesHubUser API dependency in. And then you can just give it some account credentials for NervesHub for your organization, and it can make all the API calls and have access to all the same utilities that we have for the command line utility. So you can do things like register new devices or query device lists or validate devices as well. We're in the process of updating this project that we've been doing, which is a hardware test farm that we use internally. And out of that, I've been using the NervesHubUser API to also do delegated authentication with NervesHub. So it's very easy. There's some example code that I have out there. If you're interested, you can talk to me later about it. But essentially, you can. The idea is you can stand up your own Phoenix application or whatever backend you have, and you can have your devices authenticate to your server using its NervesHub credentials, its certificates. And so you're just delegating the authentication of that device to NervesHub servers so that you don't have to carry additional copies of data or credentials. Getting started with it, yeah, you can check us out on HexDocs. If you check out the Nerves under Hub package README, that's going to have a lot of information on how to be able to get up and running. And it'll also walk you through things like setting up deployments and projects and just getting something out there to begin with. So here's another great one. Time for a demo. All right. So I know that these are way too small. All right, so I have this device here, and to speed things up a little bit, I've got this project. I've already added NervesHub to the dependency list. And in this project, I've also added, as a child of the, when running on the target, the NervesHub supervisor. And so I should be ready to go and connecting. So if I see here, that's, I compiled the firmware, I mixed firmware, I burned it onto the card. And now at this point, we can interact with NervesHub to be able to ask for some information. So I'll say mix nerves under hub.device, and we'll say list. Give me the device list. Oh, good. Any V? Yeah, thanks. Yeah. All right, so you're going to find with NervesHub that you're going to be asked for your password a couple times, all the time. And that's because in contrast to using Hex, Hex is like open source first. And so if you're like, show me packages or lists, like using the API doesn't require credentials because it's open information. Now, NervesHub is private first. So any operation that you do that requires asking the server for information is going to require you to enter a password to unlock your SSL certs that we have that represent your user. So we're just going to enter our super secret password. And here we go. We can see we have a device. It's a Raspberry Pi 3A. It's a test device, and it's running version 0.10, and it's online. And it's last connected a little while ago. OK, so let's make our super duper updates. We are so awesome at building software. This is 1.0 now. Ship it. So I'm going to build some firmware. And takes a touch. There we go. All right, so we got our 1.0 firmware, and now let's publish that to NervesHub. So we'll say mix firmware, mix nerves under hub dot firmware publish. Oh yeah. So another thing with the config is, like I said, you can sign your firmware. And so in our case here, don't mind some of this debug stuff I have, but we set the public keys to this test key. All right, so I control this key here. When we publish firmware, we need to make sure that it's signed so that, like we said, it comes out the other end with the same thing. So right from here, we can say key, and we can say, I want to sign that with the test key. And I also have set up a deployment group. Maybe it would be interesting to show that first. If I look at my deployments, we'll see I have this deployment group already set up called QA, right? Because I want to do some quality assurance on this device. And it has an active version of firmware, which is the one that's running on here. And it knows how to deploy for devices that have the tag test. All right, so from there we can do, we're going to get ready. We're going to say we want NervesHub firmware publish key test. We're going to sign it with our test key, and we're going to deploy to QA right away. And this will say, oh, are you sure you want to publish this firmware? Yep. And then it'll say, well, we need to unlock your private signing certificate. So I'm going to enter my password for that. It'll sign the firmware, and then it'll go, OK, now we need to send it to NervesHub. So you got to unlock your NervesHubUser certificate. And we'll enter that in. It'll upload the firmware and send it to the device. If we attach to the ring logger, we'll see, oh, just barely, that it so very quickly updated. We got the last one, though. I forgot. I should have attached it earlier. So that was our device. Yeah, received the message. It was told to update, and shortly thereafter, we should be able to check our device list with the right Nerves hub. We'll see if we're back up here yet. Nope, offline. You think now? Yeah. All right, we'll try it now. Offline. Oh. And now. Hey, it's online. All right. Yeah, so that's NervesHub in a nutshell. Pretty neat stuff. All right. There's been some other fun things that we've had going on recently as well. I don't know if anybody's heard, but there was a package called ElixirALE that Frank wrote a long time ago. It's a lot of helper stuff to be able to just poke around with these things. Like we were saying, like this header that's on these, all these pins, they actually do stuff. So it'd be fun to use them for stuff other than just looking pretty and calculating 1 plus 1. And so ElixirALE was a library that helps to do things like GPIO pins. Like all those pins, you imagine they're just wires, and with a GPIO pin you can be like, oh, it's set it high or set it low. It just means turn voltage on or turn voltage off. But you can mix a bunch of them together also and do more complicated things like protocols. Common ones like I2C and SPI and UART, you know, if those don't sound familiar, I mean, they're just like wires meshed together to put a protocol on top of them. You can think of like Ethernet, you know, it's something we're all kind of familiar with, but these are at a lower level. Well, anyways, ElixirALE was updated to now what's called Elixir Circuits. And Elixir Circuits has all of these components broken out into individual libraries. So if you want to be able to just work with GPIOs, like you need to be able to play with buttons or switches or like control lights, or I2C, which is common for accelerometers and gyroscopes and compasses, or SPI, which is something that oftentimes you'll find like analog to digital converter chips. You know, these Raspberry Pis, they're digital. They don't have these analog to digital or A to D devices on them. So if you need to like measure voltage, which is common for some sensors and things, you can use one of these and interface with it that way. Small displays sometimes run, like LCD displays run on SPI. And UART, which, you know, like old serial port connections, a lot of GPS receivers and cellular modems do that. And so Elixir Circuits has a lot of this helper stuff built out, and it not only works on Nerves, but it'll work on Raspberry Pis running just Raspbian or other embedded Linux devices. It also it's supported on all the official Nerves platforms. And one major change that was updated too is that it also embodied the UART portions. Naming is hard, right? And so putting Nerves behind UART when in reality Nerves UART can run on Mac OS didn't make sense. It was a little difficult to kind of comprehend for some people, and it turned a lot of people away from using it because they thought, oh, this is just for Nerves. So that's renamed and brought under the Circuits umbrella. But there's been a lot of great improvements over from ElixirALE, including that it's now modularized in a way that there's an included test backend for compilation on host. So these things are meant to be able to run on embedded Linux, and if you're not on embedded Linux, like obviously like twiddling a GPIO, there's no pins on these like laptops and stuff. So it's like doesn't really match up that way, especially on Mac OS since it's not embedded Linux. It'll swap out the backend adapter for a test one, so you can mock it, and then you can still write like nice verbose test suites in Elixir. And it also uses NIFs to be able to better performance. And as I was saying, yeah, you can swap those backends out to be able to do better testing or for porting. And it's got support for internal pull-ups and pull-downs. The ElixirALE version didn't have that. So the built-in pull-up and pull-down resistors, it's got those supported too. I'm going to show you a demo, but it's nice to be able to just understand some of this from a high level. We're going to blink that light. And so from here, this is essentially what we're doing. This header pin, these headers that are here, You can consider them wires. You can plug more wires onto. And then, like I said, when you turn one high or give it a 1, it says put voltage out. And so to turn on a light bulb, we need like power coming in one side and power and ground on the other. And so that's all that this is doing. So this is just a general wiring. And let's take a look at this one here. All right. Now this project I already have set up here. And what we did was, so in our dependencies, I just brought in 2 dependencies, Circuits GPIO and Circuits I2C. All right, and this is just how to be able to use them quick and get up and started. I SSH'd into my device that I have here. That's on a short leash, which I don't know why I did this, but it'll be viewable. Yeah. All right. So what we're going to do is we're going to be able to turn on the LEDs. This is a Enviro P hat. It's got some LEDs on the front here. It's also got a bunch of sensors. And so I know that the LEDs are on GPIO 4. And so since I was going to hold this up with one hand, I can copy and paste some code examples out of here. So the first thing I'm doing here is I'm just telling Circuits GPIO that I want to open pin 4, because according to this diagram, it's on pin 4. And I want it to be an output because I want to put voltage out. And I'm going to get back an OK and a reference here. And then I can use that reference to be able to write to this. So I'm going to then say GPIO write. I'm going to write to that LEDs reference 1 and LEDs. LEDs off. The fun thing about this, though, is that it also contains an accelerometer. We're going to see here, this is how to use I2C from a high level. I2C is a little different. Essentially, it's just a bus, and then on that bus, there's a lot of components, and those components will listen for messages that are sent on the bus to their address. So components have addresses. And it's usually just like, in this case, like a byte of hex. As this one we'll see for this component's 1D. And what you do is you just basically write cryptic information that you find from spending time reading data sheets. Or, we're not ashamed to admit sometimes we just go and look for code examples. You'll find some stuff written maybe in Python, and you can just go take some stuff from there and be like, those are the bits that I need to send, and stuff will work. And so here you just say, first thing we're going to do is we're going to do circuits demo. We're going to grab the reference to the I2C bus. All right. So now we opened up the bus, and we want to talk on the bus. We're going to write this data to the bus here. So we're just going to call this function circuits demo dot init accelerometer, and we're going to pass that our reference on our bus reference. Let's say OK. And when we read, sorry, this gets small. I'll show you this for a second. We can see here, we're just going to write, we're doing a write read. So you have to like write to tell it like what, like a command, like where you want to read from, like what data you want back. And then you'll get back the amount of data that you've asked for. And this just does a conversion here because this accelerometer is in 2G mode, and a little math for it. You can read more about how accelerometers are set up later. But essentially, we're going to get this back in. We want to be able to see this calculated where we'll get plus, or it'll be positive up to +2 or -2 Gs for this. So we're going to call circuits demo. And I have this fairly flat on this table, elevated a little bit, read I2C. And so we'll get back 3 values, right? Because there's this is a 3-dimensional accelerometer reading. And the last one is like the Z index. And you can see we're getting pretty much what we expected of 1 G, right? Does anybody feel more than 1 G of force happening here? Right? And we can turn this, like if I turn the axis, we can hit it again. We'll see now we're getting 1 G because I turned it on the other axis because it's now in a different orientation, and so on. So, there's not much code here. And one of the parts that Elixir excels at a lot is stuff like this right here, binary pattern matching, where you can pull apart binaries really easily with this syntax. It's a really big positive win on this one. All right, so what kind of cool stuff can you do with this? Well, one of my favorite things, we put together a new training this year that we're doing. We did it, the training here. We also did it once earlier, and we're going to be doing it more at some more conferences coming up, like an ElixirConf EU and maybe also MPEX New York and such. Yeah. But we took, the idea that I'm trying to get at is that we took a lot of help from things. Like there's a lot of great tools that we have in our community, Nerves and Phoenix and Schneck, and like I don't mean to just play to those people as saying that they're top players. I mean all the great packages and all the great work that we all put into this is helpful, and to be able to put stuff together and make it work quickly. And so this is an image of what our training looks like. We have Raspberry Pi Zeros with these displays on them. And what we do for it is we build a clone of a game called Space Team that's called Nerves Team. And the idea is you and your team are trying to be able to build and ship an embedded product in time. Can you do it? When everything's falling apart. So what we do is we use Schneck and Phoenix to be able to, Schneck to render to the display. We use Phoenix to be able to wire the game all up and make a multiplayer in the back end over channels. And we use Nerves to be able to run it on devices. It's a lot of fun. And all of this stuff helps you get up and running quickly. I want to really stress the fact that Nerves is not just for makers, but it's being used heavily in production. It's a really great platform to be able to build production products on. One of the people that are shipping Nerves in production out in April is APC by Schneider Electric. Makes universal power supply or uninterrupted power supply units. In this case, their product that they're embedding Nerves into is built for data centers. It's a massive battery bank there, and the Galaxy V series is going to be due out in April. In addition to APC, we also ship Nerves at Latote to be able to do some warehouse management. We build that and deploy it onto touchscreen devices and embedded devices that are used for RFID and barcodes and essentially just logistics. In addition, we also have SmartRent. SmartRent does rental property management for smart home automation for them, to be able to make it easier for rental property managers and renters to be able to control aspects of their home, like, as you can imagine, heating and door locks and stuff like that. They're running Nerves, and this is a picture of their custom board that's based on the BeagleBone platform that they're manufacturing. It's really cool. And other players, we have FarmBot. FarmBot's really fun. It's so cool. Like, it's this farming robot, and it'll just plant and water and weed, and it's like a big CNC machine. Connor Rigby is the developer over there. He's also part of the Nerves core team people. And it's funny, the last conference I went to, I came back home and I was talking to my daughter, and we were just talking about stuff, and she likes gardening, and she's like 4, and she says to me, "Daddy, can we build a robot that gardens for us? And when it plants the carrots, can it say, 'I am now planting the carrots'?" and where most parents might be like, "I don't know if that's possible," I was like, "Yeah," and I ordered a FarmBot. So proud. So from there, we also have Bowery. Bowery is a vertical farming company, and Bowery, they have 2 farms that are located just outside New York City in Kearny, New Jersey. And Bowery, what they do is they control thousands of devices that they have deployed with Nerves. That controls lighting and airflow and irrigation systems for their like hydroponic vertical farms. And they send millions of messages a day through this, and they're just loving the platform for the throughput capabilities and for the resilience in being deployed as, like, like I was just saying, immutable read-only. It's also nice to mention that as far as what's going on in the community, GRISP has just recently announced at CodeBeam, I believe, the GRISP 2 Kickstarter. It's up online, and the GRISP 2 board is going to be this NXP-based processor with built-in Wi-Fi, Ethernet, but it also has built-in Nerveskey support, and it's going to run Nerves in addition to GRISP. So it's awesome to be able to work together with Per and the team at GRISP to be able to have it so that we can kind of come together and collaborate and work on the same board together. Definitely go and check it out on Kickstarter and support the project. It looks really neat. It's going to be cool. In addition, you'll probably hear a little bit more about this during the conference, but there was a foundation that was formed called the Erlang Ecosystem Foundation. And as part of that, there's an embedded working group that myself and Frank and others Pierre and others in the GRISP community are involved in. This group is basically, I love this napkin drawing they had. It's money comes in from sponsors and corporations to the foundation, and then the board comes up with projects to work on for the working groups, and then it collaborates and captures results. And it's just a great way to be able to support the community. If you're an organization that you want to get involved by not knowing where to be able to send financial resources to, this is a great way to be able to contribute them. Other ways of getting involved, we always get asked like, oh, how can I get involved in Nerves? And it was once said best, like from a perspective of the user's case, docs and guides, like when we write them, we think that they're going to be great, but when new people come in and they're trying to use them to follow along, they're like, fall short a little. PRs, the smallest PR, one word changes, they're totally welcome. We all love this kind of stuff because it takes a little bit of the burden off of us every time. As we mentioned in the beginning, updating your make files to be able to build and underbuild is a big one. And getting involved in community groups like Erlang Ecosystem Foundation. There's also a Nerves meetup group. You can check it out on Twitter at Nerves Meetup. And it's a remote meetup, so you don't have to go anywhere. You can just hook onto this call that comes out periodically, and we all get together and talk about projects we're working on and try to be able to help each other out. And get involved in your local meetups too. If you want to learn more and you have questions, definitely try to be able to pose longer threaded questions on the forum because of its history, and it makes it a little easier to be able to spend some time getting back to people. But we're also available on Slack on the ElixirLang Slack group under Nerves Project. If you're interested more in NervesHub, there's also a NervesHub group under ElixirLang Slack. And so I'd like to also say thank you to the massive amount of community support that we've been receiving. And all the people that have been helping push PRs through, both in code and then also financial contributions that we have through our Open Collective accounts. And also I'd like to really thank Latote because they've been wonderful in sponsoring the development and pushing forward Nerves in the community. Because of Latote, I get to spend a lot of time doing this and helping a lot of other people and getting their stuff up and running with their company. So they've been really wonderful in continuing to give us some great support. And thanks to all of you for showing up, and thank you.